Hello guys, in this video we are going to discuss the solution of the problem longest consecutive subsequence. So let us look at the problem statement. The problem statement says given an array ARR of non-negative integers, find the length of longest subsequence such that the elements in the subsequence are consecutive integer. The consecutive numbers can be in any order. So for instance, if this is the array which is given to us, as we can see, these elements are consecutive numbers because of which we are returning 6 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to use dictionary or hash. Let us call that dictionary as ST. The first thing which we are going to do is we are going to store all the elements of the array in a dictionary. After doing so, we are again going to iterate on the elements of the array and we are going to check whether this element is the starting of the sequence. And the way we will be able to check this is we will check whether the element exists in the dictionary ST and element -1 does not exist in ST. In such case, this element is the starting of the sequence. If the above check is yes, then we are going to increase the value of element by 1 and we are going to check whether this element +1 exists in the dictionary or not. And we are going to repeat this process while element +1 exists in the dictionary. And while doing so, we are also going to keep a track on the count of such elements, and towards the end all we have to do is we have to compute the maximum length of the sequence and we need to return the maximum sequence length. So that's the general idea behind solving this problem, folks. Now let us take an example to understand this. So let us say this is the array which is given to us. So the first thing which we are going to do is we are going to generate a dictionary from this array. Let us call that dictionary as ST and we are going to store each elements in this dictionary. So let us say this is the dictionary which we will obtain after storing all the elements of the array in a dictionary. Now the next thing which we are going to do is we are going to iterate on the elements of the array. So the first element which we are going to iterate on is 2 and we are going to check whether 2 is the starting of a sequence or not. So remember, for 2 to be the starting of the sequence, 2 should exist in the dictionary and 2 minus 1 which is 1 should not exist in the dictionary. So what do I mean by this is, let us say over here element is equals to 2. So for this element to be the starting of the sequence, this element should exist in the dictionary. So element in ST and element -1 should not be there in the dictionary. So let us check that whether this condition is satisfied or not. So as we can see, 2 exists in the dictionary and 2 minus 1 which is 1 also exists in the dictionary, because of which 2 is not the starting point of the sequence. Because of which we are going to ignore 2 and we are going to move to the next element. The next element is 6. 6 again exists in the dictionary and 6 minus 1 which is 5 also exists in the dictionary, because of which 6 also is not the starting of the sequence. Now we'll move to the next element which is 1. And for 1, as we can see, when element is equals to 1, 1 exists in dictionary and 1 minus 1 which is equals to 0 does not exist in dictionary. Because of which we realize that 1 is the starting point of the sequence. Now once we have realized that 1 is the starting point of the sequence, we are going to iterate from 1 all the way till the elements exist in the dictionary. So the first element which exists in the dictionary is 1. So element equals to 1, it exists in dictionary and count is equals to 1. And since we have already operated on 1, we are going to remove this 1 from the dictionary and we are going to proceed forward. Now the next element is 2 and we are going to check whether 2 exists in the dictionary or not. Since 2 exists in the dictionary, we are going to increase this count by 1 and now count becomes equals to 2. Again, the same thing we are going to do. Since 2 we have already operated on, we are going to remove 2 from the dictionary. Now the next element which we will have is 3 and we are going to check whether 3 exists in the dictionary or not. Since 3 exists in the dictionary, we are going to update our count by 1 and now count becomes equals to 3. And again we are going to remove 3 from the dictionary. We'll look in a bit why we are removing elements from the dictionary, but for now let us proceed forward. Now the next element which we have is 4 and we are going to check whether 4 exists in the dictionary or not. Since 4 exists in the dictionary, so the count gets increased by 1 and count becomes equals to 4. And again we are going to remove 4 from the dictionary. So 4 is being removed from the dictionary. Again we move to the next element, and the next element is 5, and we are going to check whether 5 exists in the dictionary or not. Since in this case 5 exists in the dictionary, because of which we are going to increase count by 1, and now count becomes equals to 5. And we are going to remove 5 from the dictionary. Now the next element is 6, and we are going to check whether 6 exists in the dictionary or not. Since 6 exists in the dictionary, we are going to increase count by 1. So now count becomes equals to 6. And we are going to remove 6 from the dictionary. Now the next element is 7, and since 7 does not exist in the dictionary, we are going to break our loop from here. And for now, our answer will be equals to maximum of answer and count, and the initial value of answer is equals to 0. So the maximum of 0 and 6 is 6, because of which for now the answer equals to 6. Now we move to the next element. The next element is 9 over here. Again we are going to check whether 9 is the starting point of the sequence or not. So as we can see, 9 exists in the dictionary, and 9 minus 1, which is equals to 8, does not exist in the dictionary, because of which 9 is the starting point of the new sequence. So for that, we are going to have element equals to 9 and count is equals to 1. And then we are going to remove this 9 from the dictionary, and we are going to move to the next element. The next element is 10, and since 10 does not exist in the dictionary, because of which over here count is equals to 1, and again we are going to compute our answer. Answer is equals to max between answer and count, since the maximum is 6 in this case, because of which answer remains equals to 6. Now after doing so, we are going to move to the next element. Now the next element is 4, and here comes the reason why we were removing the elements from the dictionary. Now since 4 we have already operated on. Remember folks, when we were operating on this sequence, we have already operated on 4. And while operating on this 4, we have removed that 4 from the existing dictionary. Because of which when we are encountering 4 again, this condition will not be satisfied, because of which we will be able to avoid recomputation. And that is the reason folks why we were removing elements from the dictionary. And the same thing goes for 5 and 3. In this way, we have operated on all the elements of the array, and the answer we have obtained is 6, and this is what we are going to return. So that's the discussion of solution folks. Now let us discuss the pseudocode of this problem. So let us say we want to compute longest consecutive subsequence, and an array is given to us. For this, let us have a dictionary st, and let us take answer is equals to 0. And the first thing which we are going to do is we are going to store all the elements of the array in the dictionary st. So for element in ARR, all we have to do is st of element equals to true. And then again we are going to iterate on the elements of the array. So for element in ARR, and the first thing which we are going to do is we are going to check whether this element is the starting of the sequence or not. So for that, if element in st and element minus 1 not in st, in such case this element is the starting point of the sequence. Once we have realized that this is the starting point of the sequence, what we are going to do is we are going to take current, which is equals to element, and we are going to take count, which is equals to 0. And then we are going to iterate on current while current in st. And within this loop, all we have to do is first we have to delete the element from the dictionary. So let us delete that, del st of current, and then we need to increase our current by 1. So current becomes current plus 1, and we need to increase our count by 1. So over here, by doing current equals to current plus 1, we are essentially checking whether the next element also exists in the dictionary or not. And towards the end, all we have to do is we just have to compute our answer, which is equals to maximum of answer comma count. And towards the end, we just have to return our answer. So that's the pseudocode folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here we have our dictionary st, answer equals to 0, and then we are iterating on the elements of the array, and we are pushing all these elements into a dictionary. Then we are iterating on the elements of the array again, and we are checking whether this element is the starting of the sequence. If this is the starting of the sequence, then we are setting current equals to element and count equals to 0, and then we are checking whether current exists in ST or not. If that is the case, then we are deleting the current element from ST, we are increasing count and current by 1, and towards the end we are computing answer, which is equals to max of answer comma count, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Over here I'm using an unordered set ST, answer equals to 0, and then we are inserting all the elements of the array in the unordered set ST, and then we are again iterating on the elements of the array. We are checking whether this element is the starting of the sequence or not. If that is the case, then we are setting current equals to element and count equals to 0, and then we are iterating on current while current exists in dictionary. In such case, first thing which we are doing is we are removing current from the unordered set, and we are increasing current and count by 1. Towards the end we are computing answer, which is equals to max of answer comma count, and returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.